So let me introduce you to Techcanvass. Techcanvass is an IT certifications training organization for professionals, wherein we help students to crack their certification exams in first attempt. And we are authorized training center for IIBA Canada, and we are authorized training provider for PMI. So we provide certifications related to IIBA and PMI project management as well. So today the session is about data science, and we have with us Priya, who is a certified IIBA business data analyst, and she is working in the industry for past 10 plus years in business intelligence with an MNC, the public sector with Teach for India, and curriculum development with the Lead School. And I would request Priya to take this session ahead. Thank you for joining and hope you all have a great session.
Hey, thanks, Soumya. Thank you so much. So, a warm welcome to all of you. And yeah, I hope I'm audible. Okay, all right. So, yeah, let's check out what we'll be covering today in this session. So, first of all, we'll begin with what is data science. Then we'll move on to how do data science projects actually work and how are they different from other projects. Who is actually a data scientist? What are their skills? What work do they do? Some other roles in a data science project. So we'll be looking at two or three different roles. Other people who work in data science projects, and finally we'll look at the career progression. Right. So yeah, let's begin. So first, we'll begin with what is data science. We'll define data science with some examples. Before that, just to get a quick background, if you can just put in the chat the number as to what your background is so that we get a general idea of the audience. We have one entry. All right. Okay, great. Thanks for sharing, Tom. All right. So on to understanding what is actually data science, right? So if you look on the internet, there are like multiple definitions, and people have tried to explain what is data science. So basically, data science is a very vast field, right? And it involves a lot of different branches. So it can be quite complicated to exactly define what data science actually is. Before we move into actually understanding what data science is, let us look at how data science is actually improving your life, right? So, well, many of us might think that data science is used only in organizations for, say, business decision making, right? But you may be surprised how often you have come into contact with products and services empowered by data science. Take the example of Netflix, right? So Netflix collects enormous amounts of data, like the content you watch, the time and date, your ratings, and much more. And how does that help? Well, they get to know the trending TV shows and movies. They analyze this information using data science algorithms, and they decide what content to buy or create in the future. Or they provide us personalized recommendations, right? What movies we would like to watch. And this helps keep their customers happy. So there's a lot of things that Netflix does using the data that they collect from us. And how does this help us? So it basically saves us time searching for content that we like, right? We already get a curated list of content that we might like, but we would not have known if it was not directly displayed on our Netflix screen. And definitely, we get a list of trending shows and movies as well. Example is logistics and transportation. So we want our packages delivered as soon as possible, right? The online deliveries that we have. So every now and then we track where our packages reached, what is the ETA. So well, data science algorithms, they provide the delivery speed and they provide accurate real-time updates as to when our package will be delivered. So data science not only helps in this, but it also helps predict and anticipate the peaks in demands, so that retailers, they can stock up on products appropriately and deliver them to their customers on time. And it also provides the most optimal travel route for delivery shipments. So Amazon gives 2-day deliveries to their prime customers, right? And they keep them happy. So this is one more example where we are interacting with data science. And lastly, the most popular one is Google search, right? Which provides the best possible matching results using data science algorithms in a fraction of a second. So if you can look at the number of results which were shown in just 0.80 seconds, so it's quite surprising, and it's quite overwhelming as to the speed with which Google is working, right? So these are all different examples of how data science is improving our life. And definitely I feel these examples make data science more accessible, right? So now let us go in a little more depth about data science, right? So in the simplest term, data science is an iterative process involving various techniques, and these techniques are used to extract value from data to solve business problems, right? So it has become an essential tool for any organization that collects, stores, and processes data as part of its operations. And nowadays, almost all of the organizations do that, right? Everybody is collecting and working with data. So, data science now heavily relies on machine learning and data mining in today's context. Data science is commonly used to solve business problems like, for example, let's say classification. So, understanding if the transaction is fraudulent or not. So, we classify the transaction as fraudulent or not fraudulent. Clustering, in which we group customers based on their purchase patterns. Recommendation. So this is what we saw about Netflix, right? So which movie would the customer like to watch next? So we get those recommendations. Same recommendation system is used by Amazon as well to display the products that we would like to buy, or people who buy different products together. So all these recommendations are shown on our Amazon page. Regression. So wherein we predict the interest rate of a loan, right? So we are predicting what is the interest rate that can be applicable. Or association analysis, wherein we talk about market basket analysis. For example, like what are the different products that people would like to buy together? And many times stores often keep these products close by so that people can easily grab those products from the shelves. And yeah, definitely make more profits. And time series forecasting, right? So predicting sales based on seasonality, wherein we are looking at the timeline and predicting the sales. So these are a few, examples of how data science is used to solve different business problems. There are quite other techniques and different ways as well, but these are a few common ways in which data science is commonly used. Right. Now, in order to understand data science in more detail, let's look at how it is used in projects. So, what is the data science project framework? So, this value extraction from data is done systematically using a framework. Now, why a framework, right? So, a framework provides a structure to our thinking about handling data analytics problems, like how we should go about handling the different stages, what should follow the previous stage, what is the right approach, right? It gives us that outlook, it gives that structure to our thinking. So, we will be looking at a widely accepted framework called CRISP-DM, that is Cross Industry Standard Process for Data Mining. So here, this outer circle, it denotes that the process does not end with deployment here, that is implementing the final product when the product goes live, but it can lead to new projects or maintenance or upgrades and learnings for the next projects. So let us explore this framework in more detail. So the first stage is business understanding. So now the complete data science cycle revolves around the business problem. Now, definitely the key to great success is correctly translating the business problem into one or more data science problems, right? When we do that correctly, only then we'll get the correct outputs, which is useful for the business. So it is essential to know the underlying business practices, the context, and the business processes generating the data. So without well-defined and well understood problem statement, it is impossible to select suitable data sets and as well as select correct algorithms for analysis. So business problem and context and what data the business processes are generating. These are two essential concepts in defining or understanding the correct data sets and selecting the correct algorithms. So now take an example of predicting if borrowers will pay off their loans on time or not. So all the details related to the borrower, like say customer demographics, say the annual income, current liabilities, the credit score, etc., need to be assessed, right? So thus the business problem statement stated in simplest terms can be formulated as: can we predict if a borrower will pay off their loan on time or not? Right? So basically, understanding this business, what exactly is needed by the business, is very important. I can I request everyone to please go on mute? Thank you so much. Right.
Priya, you're still muted.
Can you hear me?
Yeah, Priya, now we can hear you. You just got on mute. I don't know how.
Oh, anyway, okay, all right. So, what was the last thing that you guys could hear? Can someone please let me know?
You asked everybody to mute themselves.
Oh, okay. All right. Great. Thank you so much. All right. So, yeah, what I was saying was, yeah, this was the last thing that we discussed about business understanding, right? So, a good understanding of business, what the business needs, is quite important because that is going to impact your entire next process. The next step is data understanding. So, the data is the raw material that is used to build the solution, and it must be picked very carefully. So let's say in the above example, say suppose we could get data for borrowers with an annual income of say $25,000 and above, right? Now this is an important feature like the annual income, right? Or this is the data that data variable that we will be using in predicting loan payment. But in the later stage of modeling, the model will not predict correctly for income less than $25,000, right? Because we have data only greater than $25,000. So the underlying issue here is not capturing sufficient data representing the real world. So a fundamental understanding of the domain is essential to avoid such failures, right? So we may collect data as say CSV files, text files, relational databases, or obtain data from the internet using web scraping or APIs. Nowadays, unstructured data like music or images, audio, text files. There are a lot of different data types that we can collect, right? Or businesses rather use. So many times we may not have suitable data set, right? So in that case, we can consider buying or creating it through a survey. So in this phase, basically, we also look at how to store this collected data. Now, once we have our data collected and ready, next step is data exploration. So exploratory data analysis is used to, better understand and prepare data in a way suitable for advanced analysis. So different analysis techniques need the data to be in a particular format, right? So we need to prepare the data for advanced analysis. We cannot directly use this raw data that we have collected. So it is helpful to understand the different distributions and interrelationships between variables that we do using the exploratory data analysis phase. Data visualization is widely used in this process. So for example, we can use a histogram for annual salary distribution and see the range where most of the salaries in our data set fall. Or we can use a scatter plot for the relationships between the credit score and the interest rate. So using this, the data scientists understand patterns in the data that they have collected, and this enables them to decide which machine learning techniques or which other algorithms are likely to perform the best. Right? So once we have a general understanding of what data we have, we then go into depth of data preparation. So this is the most time consuming, right? Most time consuming step, but very critical before we jump into the actual data analysis. So here we look at some of the most common tasks performed. So again, this is not a comprehensive list. There are many other tasks performed under this section, but we look at some of the common tasks. So the first one is data merging. So majority of the time, we will have to combine data from multiple sources, right? Because you'll not have just one data source. We'll have data coming in from different business processes, and we'll have to combine them at some stage. So we will then, once we combine the data, we will have a single source of truth. That is all the required data assembled in one place. So in the above example, the demographic data, loan information, bank account details, and other required data will be collected separately and then merged, right? So once we have the merged data, we'll have the entire data collected in one place. Next is data quality. So data quality is the most significant point for anyone working with data, right? You must have heard the phrase that the quality garbage in, garbage out, right? If your data quality is not good, your output of the model is also not going to be good. So this is one area where, data scientists, data analysts, they spend their majority of the time in ensuring that they have good data quality, because the entire next steps would be dependent on the quality of data that you have. So multiple things are checked for assessing the quality of data, like incorrect or corrupt values, right? So for example, the data may have incorrect values, like the credit score is recorded as 900, whereas the normal range is from 300 to 850, right? So these are some incorrect values that need to be handled. Or say during data merging, annual income from United States and Germany may look different, right? And definitely they mean different values, right? But they, I mean, same values, but they are represented differently. So we need to correct these. Next is missing values. So some data definitely might be missing. You'll never get clean data sets, right, with all fields available. So there would be missing values like, say, for example, a blank credit score in one of our records. So most of the models will not perform well with missing values, and it may also affect the mathematical calculations, right? So correct replacement or removing those records is important based on what your business requirement is. Handling or detecting outliers. Now, outliers are basically anomalies in the data set, that is extremely small or big values away from the expected range of values. So if we find that a few people's reported annual income values are, say, tens of millions, then we know that these are some incorrect values, right? Or if the annual income is, as we saw, like 60.025 in case of representation in the German format, when we merged data. So this is an outlier and needs to be corrected because of the erroneous data capture. So outliers basically mislead the training process of the model and they affect the accuracy. Right, so these are some of the few tasks performed under data quality. That there are quite a lot of tasks performed, but these are a common few list of tasks. Next is data transformation, right? So the powerful analytical tools that we use often bring some restrictions on reading and processing data. So whatever machine learning models or algorithms that we use, they have some restrictions. So usually the format will be different from the naturally produced business data. So let's look at how data transformation is done. For example, feature selection, right? So let's understand that not all the data or data fields that we collect, right, in the data understanding phase, they may be useful for our model analysis. So we will select only a few useful fields, fields also called as features, right, which will be useful for our analysis. And we may also create some new ones using the existing fields, right? So basically maybe combine two fields and merge those fields and create a new column, or transform those fields into some calculations as needed. So the final set of fields is called as features. And these features will be the input to the data model that we will be looking in the next step. Data type conversion. So basically, many models can handle only numeric data. So say suppose you have the credit score as poor, excellent, poor, good, and excellent. We may have to convert them into a numeric score by encoding a dummy value to each score. Right? So this is just one example. Next is feature splitting. So as we talked about feature combining, feature splitting is just the opposite. So for example, say we may have the state and country names clubbed in our incoming data, right? But for our regional analysis, we may want to split and separate the state and country into two different columns. So yeah, this is done using feature splitting. So this is just a gist, and there are many such techniques that data scientists use to transform and prepare the data. Right, so this was all about data preparation. Next, we move on to modeling and evaluation. So this is the stage where the real magic happens. So data science algorithms based on statistics and math are used to automate tasks by building models, right? So basically, the business problem and the data available, they dictate the model selection process. What exactly is the need of the business? Training and testing data sets is a common way of, actually training and testing the model that we have built here. So the standard thumb rule is to split the data with features and known output. That is, let's say, for example, whether loan is paid, yes or not, into 80% trained data set and 20% as test data set. So basically, we will use some data to train our model, and we'll use the remaining 20% to test our model. So for example, say our model uses only two features for simplicity, credit score and annual salary, to predict whether they will pay the loan on time or not. So the model will learn how to do this prediction using the trained data. And we will assess the model on test data to see how the model that we have prepared here is actually performing. And how will we do this? We will do this by comparing the actual and the predicted results, right? So basically here we are testing or assessing our model. We keep fine-tuning the model until the desired accuracy is reached. So again, this is an iterative process. So here are some of the basic steps performed by the data scientist when building a model, right? So we built a model using this training data set, which is a part subset of our actual data. Then we built the model. We assessed the model using the test data, which is again fractional part of our actual data set. And we fine tune, fine tune our model, make some changes, again go through this process, assess it. And once we are happy with our outcome, then we say that our model is finalized. And lastly, we evaluate the results. So once the model has reached, desirable accuracy, the insights or relevance to the original business question, the business impact, risks, and much more have to be communicated to business decision makers, right? So business visualizations and data storytelling are essential part of this process. So once we get the results, we know the insights, we need to communicate them to the business end users. And yeah, you must have heard of data storytelling, visualizations. So these are some of the techniques that are used in this phase. Once the decision is made to implement the changes, right, we move on to the deployment stage. Once we get a go ahead from business that everything goods look, get up all the approvals, we go ahead to this deployment stage. And this is where our model goes live, right? Or we become production ready to work in the real world. So the results of the data science process have to be assimilated into the business process. And this is usually some maybe software applications. And once implemented, the models have to be monitored and maintained. We cannot just implement and say our work is done, but it needs continuous monitoring and maintenance like any other system. So the model in our example can now be used to predict whether new customers or borrowers will pay their loan on time or not, by integrating it into the actual loan approval process, which the business might already have, right? So this is something that we will integrate into the system. Now, though we have many algorithms available, right, the real skill lies in the data scientist's ability to proficiently transform the business problem into a data problem and then select the suitable algorithms. So the CRISP model provides a very simple yet effective outline, which we just saw, and the sequence of the phases in a data science project. Now, of course, the sequence of these phases is not rigid, right? So moving back and forth between different phases is always required based on, maybe we might have to collect new data. Say our earlier collected data was not sufficient or some data preparation steps were missing. So we might have to come back to some earlier stages. So it is always an iterative process, right? So this was a very brief general understanding of how data science projects are actually implemented, how do they work, and what are the different steps or the different phases that are involved. So now let's look at some of the popular data science tools which are commonly used. So data scientists must be able to, build and run code to create different models. So the most popular programming languages are open source tools that include or support pre-built statistical, machine learning, and visualization techniques. So R is an open source programming language and environment for developing statistical computing and graphics. So it is one of the most popular languages used by data scientists. Another one is Python. So Python is a general purpose, object-oriented, high-level programming language. So several Python libraries support the different data science tasks. So we have NumPy for handling large dimensional arrays. We have Pandas for data manipulation and analysis, and Matplotlib for data visualizations, and different libraries for machine learning algorithms and statistical analysis as well. Big data processing platforms like Apache Spark and Hadoop, right? They are also very commonly used. They help in processing data parallelly, right? Like big data and large amounts of data. And lastly, we have Tableau and Microsoft Power BI, right, for visualizations and basic machine learning algorithms, data exploration, data visualizations, and much more. So these are basically business intelligence tools. They can be used by data scientists as well as business users. So again, this is not a complete list. It's an example of a few popular data science tools used. Now, a quick understanding of why data science is actually used by organizations. So, any ideas on why do you think organizations use data science so heavily? Maybe you can ping in the chat box any thoughts that you have. Why do you think data science is used by organizations so heavily? All right, let's take a look at some of the reasons why organizations use data science. Right. So here are a common few reasons. Like definitely, organizations aim for higher ROIs. Right. So take example of Netflix. By implementing different data science algorithms and keeping their customers happy, definitely their ROI, their sales definitely are growing. Data science helps in more efficient operations, right? As we saw in the logistics example. So, efficiently managing the travel routes, right? That is nothing but efficient operations or getting an idea on the demand and supply. So, these are nothing but handling your operations efficiently or faster time to market and increase customer engagement and satisfaction. So, keeping your customers happy, engaging more customers. Empower and facilitate better decision making. Obviously, your decisions, when they are data driven as opposed to intuition based, they will definitely be much better, and you'll have like a data proof as to why you're taking those decisions. So, definitely, they'll lead to better decision making. Stronger business performance. So definitely industries that are using data are taking the lead in the market versus those industries who are not yet working with data. So definitely you will stay ahead in the market. Cost savings, yes, and smoother business processes and workflows. So yeah, these are a few reasons why data science is so heavily used in the organizations. Now, moving on to the next phase of who is a data scientist, right? What skills and competencies are needed? So, now the definition of what a data scientist does varies from organization to organization. If you search online, you'll find many variations of what a data scientist is actually doing. So, let us understand broadly who a data scientist is. Basically, I would say that they are curious researchers, right? So basically, they are specialists who apply their expertise in statistics and building machine learning models to solve complex business problems. Data scientists here basically they tackle open-ended business problems and business questions. And as we saw in the first step, right, they convert these business problems into mathematical models using structured and unstructured data, and this is used to identify patterns and derive accurate predictions or, in general, business insights. They must have exceptional industry specific knowledge because here they are trying to convert the business requirement into mathematical models. So they should know what actually is required by the business, how the business works, all the other nuances of the business working. So yeah, basically, they are experts in statistics and machine learning, building machine learning models. So let us look at how a day in the life of a data scientist looks. So now that we understand each of the roles, the skill sets required are very important. Again, this is a broad list and skills may change based on the organization and the job profile. So basically, a data scientist will work with the management to prioritize business needs. So there might be multiple business requirements, right? But what is actually required at that time? So they basically uh, sit down with the management, look at the business problems, prioritize what is urgently required, and then they uh, take that problem to be solved using data science. They identify unexplored data opportunities. So maybe everything is going on fine in the business, but there may be some unexplored opportunities or some ways in which you can improve the business, right? So the data scientist is always hunting or looking out for new processes, say, or new opportunities to improve the business within the organization, and looking for new changes or new ways to take the business to the next level. They analyze stakeholders' problems and frame a data science problem from their perspective, right? Because in the end, they are going to transform this business problem into a mathematical or statistical problem to be solved. So here again, they interact with different stakeholders to understand the problem from different perspectives. Then they automate the model and convert it into end products with the help of data engineers to make it easily accessible. So this is what we saw in the CRISP DM model, right? Once we have the insights, they visualize the data findings, summarize and synthesize the data, and finally present these recommendations to the businesses in a clear and logical manner. So again, now presenting these recommendations is very, crucial, because they should be in a clear and simple manner in which business people can understand. So the visualizations or explanation should not be too technical. So again, this is another aspect on which data scientists work. Here they are working on extensive technical problems or mathematical solutions, but here they again have to come back and explain the outputs or the insights to business users in a simple and clear way. And yeah, develop machine learning models. So this is the general way. So they develop the models, the requirement gathering, data preparation, exploratory data analysis, feature engineering, model building. These are some of the few steps that are performed by data scientists in everyday life. So this is a broad list of the skill sets, required. So yeah, data wrangling. Again, data scientist is working with data, right? So data wrangling and cleaning the data, working with data is all part of their skill set. Data mining, wherein they find patterns or different structures in the collected data. SQL, NoSQL, and database knowledge, or machine learning, AI, deep learning. Proficiency in at least one of these programming languages. The different big data techniques, because nowadays data is slowly moving towards big data, right? So you have a lot of unstructured data, and data scientists need to know the different techniques used for handling big data. And lastly, data visualization, maybe using popular tools like Tableau, Power BI. So again, a generalized list of some of the skill sets required by a data scientist. Again, these skills may change based on the organization you're working for or the job profile you're looking at, right? The soft skills, right? So now data scientists obviously are working with complex mathematical models, but as we saw, they also need some soft skills wherein they are interacting with people, interacting with the team, communicating with different stakeholders. So yeah, definitely analytical thinking and problem solving is required. Then they need creative thinking, because they are let's say, for example, they are looking at improving the business, right? So what are the different ways in which business can be improved? How will different techniques help in improving the business? They need to be creative in finding out the problems as well as the solutions that will help the business. Business and domain expertise, right? This is a must. Leadership and influencing. So yeah, basically data scientists may be handling different teams or handling different parts of the projects. So they definitely need that leadership skill. And influencing, I would say, when they are explaining the insights derived to the business stakeholders, right? They have to explain why them what they are suggesting is correct for the business, so they should be able to explain it accurately. Next is communication with different stakeholders. And lastly, adaptability. So basically, being open to like whatever changes that may be required midway in the process. So maybe you might have to go back to some phase earlier in the project, or maybe some rework is required, some business requirement changes, business needs changes. So you have to be adaptable in whatever you are doing. You cannot stick to one thing saying that no, I will continue doing this only. So you have to change as per the business requirement changes. So yeah, these are some of the few soft skills required by the data scientists. Right, some interesting statistics about the salary, job roles. So yes, definitely data science is an exciting field with a lot of job openings currently available as well as coming up in the future. Right, so we explored who is a data scientist, we looked at the skills and competencies. Now let's move on to the other roles in data science projects, right? So we'll explore the data analyst role, data engineer, and the business data analyst role here, right? So let's first understand the data analyst role. So I would say data analysts are problem solvers, right? So if you have good critical thinking skills and you enjoy working with numbers to solve complex problems, you will enjoy a career in data analysis. So in simple terms, it is analyzing and visualizing data to derive insights for better decisions, business decisions, I would say. So the typical workflow starts with asking the right questions, as this will be the basis of the analysis. So collect and sanitize data, prepare it for an analysis, perform statistical analysis to find insights. So basically, data analysts, they are looking at the existing data to find different insights valuable for the business and present them visually to the end users in understandable English or plain English, and to enable decision makers to decide the next strategies. So basically, yeah, presenting insights visually is an important part of a data analyst's job. Again, important to remember, data analysis is not just statistics and it does not include decision making. So they basically give all the facts and they present all the insights to the decision makers. And then the decision makers are the people who actually come up with decisions. So data analysts don't make any decisions. They focus more on analysis and data communication. So yeah, let us look at what kind of analysis do they focus on. So they basically focus on diagnostic, descriptive type of analysis, right? So basically, for example, conducting root cause and failure analysis in supply chain analytics. This is nothing but diagnostic analysis where they are trying to find this root cause, why something is failing. Or descriptive analysis like last quarter customer retention summary statistics, wherein they are just simply describing the data. So basically, they data analysts mostly work on diagnostic and descriptive analysis. I would say less on predictive and prescriptive analysis, which are the next steps ahead from these two types of analysis. Right? So yeah, data analysts are problem solvers, I would say. So yeah, and yeah, one more example of diagnostic analysis, say investigating the dipping revenue in a particular quarter. So again, you're trying to find the root cause of dipping revenue, right? So a few examples of where data analysts focus their work on. This is all about data analysts looking at data engineers, right? So I would say data engineers are the backend builders. So basically, data engineers, they lay the foundation of any data science project. They develop end-to-end architectures right from facilitating data collection to getting the end product ready, right? So they are specialist programmers who, harvest data from multiple sources, create craft meaningful data sets, and in the end connect them together into an analytical infrastructure for the entire organization, right? So they manage the entire data collection, manipulation, maintenance, and all of that. So yeah, as I said, they maintain the complete data architecture, right? Which makes accurate data accessible to all people using data, I would say, not just data analysts and scientists, but everyone who is using data, right? So they make good data accessible to everyone. Now, according to IBM, did you know that poor data quality costs the US economy up to $3.1 trillion yearly? So poor data quality is the root cause. This tells us how important the role of data engineers is, right? So one simple image, but yeah, this says quite a lot. There can be no data science without data engineering. So basically, data engineers lay the foundation for the work that a data scientist does, creating and maintaining a complete data architecture for data scientists to use. This image indeed shows their importance, right? And next is the role of a business data analyst, right? So a business data analyst, basically, they are business analysts with a strong business understanding. So they know what the business needs, how the business works. They have the entire business understanding. And they also have some idea or basic understanding of data analysis, data science techniques, data science processes. So basically, they combine the knowledge of both business as well as the data science side. And this enables them to work together or basically lead business data.
Priya, you are on mute again.
Really sorry, I don't know why this is happening. All right. Okay. Great. So let us look at what a business data analyst does. So this is actually, I would say, quite a new role, right, in the market right now. So basically, this was created to bridge the gap between business analysis and data scientists, what the work they do. So basically, both of these teams work independently, right, in many of the organizations. But when they work independently, successful completion of projects is like highly impossible, because business and data need to work together for complete successful completion of the projects. So basically, a business data analyst, they define and formulate the research questions based on the business needs, what the business actually requires. Next, they manage all stakeholder communications, like gathering, requirements from the stakeholders, and in the end, formulating what is the final requirement for the business. They plan the business data analytics approach, how business data analytics should be implemented along with the data scientist. Now, again, remember one important thing here, because they know the data scientist terminologies, right? They can easily and efficiently interact with the data scientists and explain what the business needs to the data scientist. So the data scientist's work is also more focused on the actual requirements. So many times it may happen that data scientists may not understand end-to-end business and business how it works, like a business analyst. So a business data analyst here plays a very important role. Next, they aid the data scientist in data collection, data validation, and performing exploratory data analysis because they have all of this knowledge, right? They work closely with data scientists to combine the domain knowledge with technical knowledge. In the end, they assess this very important question: is the result derived by the data scientist answering the business questions? Because in the end, this is the goal that we are looking at, right? And someone with business understanding as well as technical understanding is the person who can answer this question correctly. So, a business data analyst is the best person who can work on this. And lastly, it takes business data analyst takes some of the role from the data scientist in communicating the findings to stakeholders using data visualization and storytelling. So in many organizations, if this role is not there, the burden is on data scientists to perform the entire cycle, right from business requirement gathering till communicating to the stakeholders. But with this new role of business data analysts, this process can be done more efficiently as well as more effectively because they have the required skill sets. And lastly, they work on the business data analytics approach at the organizational level as well. Like, for example, creating the data strategy or creating different data roles and, hiring people for those data roles. So a business data analyst is quite a vast role, and they kind of lead the business analytics process in the organizations. So we'll be covering more about business data analysts in another session as well. So yeah, more on that in that session. So one quick exercise for all of you, would love your inputs. So basically what we are going to do is I have some tasks here, right? And we have the roles of a data engineer, business data analyst, and data scientist here. I want you guys to help me map these tasks under these roles, like which role is performing what task. So maybe if you can start off with the first one, performing business problem discovery. Who do you think performs this task? If you can type in the chat box, that would be great. Okay, Tom says BDA, business data analyst. Let's check. Yeah, absolutely right. Thanks, Tom. Next is maintain the data architecture. Yeah, we're getting quite many responses. Thank you so much. Okay, data engineer is one response. Any other responses? Okay, let's check. Yeah, that's correct. Exploratory data analysis. So again, just a hint, this can be done by a combination of roles as well. Okay. Any other responses? We have data scientist, data engineer, and BDA. We have BDA. All right, let's check. Thank you so much. Okay, so this is basically done by data scientists and business data analysts majority of the times. Next is perform the actual data analysis. Who performs the actual data analysis? Okay, data scientists. All right, let's check. Yep, they perform the actual data analysis. Technical visualizations. Who creates technical visualizations? Okay, we have quite a few responses. Let's check. Okay, technical visualizations are by data scientists, business data analysts create business visualizations, right? To communicate with business stakeholders. Use data storytelling to communicate insights. Okay, so again, this is a combination, depends on the role in the organization. Data scientists as well as BDAs both can use this information, use data storytelling. And lastly, build systems to collect and convert data. Yep, we are data engineers. That's absolutely correct. Great work. Thank you so much for your responses. And I hope you enjoyed this short activity in between all the technical and theoretical things that we were discussing. All right, great work. Thank you so much. Let's move on to our last part of looking at the career progression, right? So, a general different steps of how you can progress on the career end, right? So, basically, I would say that majority of the data scientists start their journey with data analysis. So, again, majority of the times, right? So once you have a good understanding of handling data, working with diagnostic and descriptive analytics, uh, you have some experience working as a data analyst, you then move on to a data scientist's role. Once you gain expertise, you can move on to a senior data scientist role. You can move on to a manager or architect role of the entire project. You can be a data leader, moving on to chief data officer or other CXO positions, right? So basically, I would say that junior data scientists are given a task instead of finding one, right? While mid-level data scientists, they actually go ahead and find the different tasks or different processes in which they can improve the business. So that is a big difference between mid-level and junior level data scientists. So that is how you can progress. So senior positions, basically, they have higher level of functional expertise. They understand the business, they have the business understanding to a higher extent. They identify and develop solutions for high impact problems, right? And they lead large projects to become senior data scientists. So basically, larger is the impact, greater is the progress in your path, right? Management roles, basically, under data science, they focus on improving the business decision making or building leadership skills along with data skills. And finally, they become into a data analytics director or chief data officer, or they move into project management and all of those management roles. We also have specialist roles wherein you can specialize into one of these specialized fields, like a machine learning engineer, neural net engineer, AI expert, natural language processing expert, deep learning expert, and so on. So you will gain expertise in these particular fields. So this is a general understanding of the career progression. Some interesting statistics about data science. Quite an interesting field, I would say, and exciting as well. Here are a few of the job openings from LinkedIn from March 2022. So, yeah, I would say it's an exciting profile, and I would just like to give you a simple roadmap, right? So, basically, data science is an exciting field with many opportunities, but of course, it is not so simple, and you will have to put in efforts to gain expertise, right? So, basically, you will need a good amount of experience in the domain as well as technical knowledge. So, basically, advanced math, probability, and statistics. So you should have a very good command in math and statistics, as this is the foundation of machine learning algorithms. Right? Advanced, advanced SQL, Python, and R. So these are the core skills of data analysts, data scientists, to which they use during transformation. So basically, these skills are used to transform raw data to business insights. Machine learning, cloud computing. So basically, you should start developing these skills to, build predictive models, and you should be able to process large data sets. So machine learning is a very common technique used by data scientists. So yes, good understanding of all the algorithms used. Data visualization, right? So the outcome received out of the predictive models is represented with the help of interactive reports and dashboards. So you will need a good knowledge of data visualization. Lastly, not lastly, but yeah, business acumen. So you need a good understanding of the requirements, to analyze data from the business perspective and develop solutions which are aligned to the business, right? This is very important. And yeah, lastly, what you can do is portfolio creation and networking. So basically, yeah, you should be able to present the findings in with confidence, and should be able to answer the questions coming in from the business, right? So basically, I would say that you need to develop some advanced skills, right, based on the analytics branch you are passionate about. So take stock of your current skills and learn, say, SQL, NoSQL, Python, R, machine learning models, uh, distributed frameworks also like Hadoop, cloud computing, because those are used nowadays in the business. And yes, problem solving and expertise in the business domain that you're currently working. Another important thing is, like, if you're new and you want to step into data science, you can create a portfolio, right? So pick up a business problem. So there are many freely available data sets. Ask the right questions using the data. Work on, feature engineering, like working on creating different features. Build some machine learning models on that sample data set. And in this way, you can showcase your skill sets if you're starting newly in this field. Maybe you can take part in challenges or competitions, create a GitHub account and upload your projects for employers to view. And you can go ahead for different type of certifications as well, right? The Open Certified Data Scientist or Google Data Machine Learning certification. There are many certifications available. And lastly, yes, network with people to understand the current market trends, nature of work, track your development, skill development, and your entire preparation journey, right? So this was a general roadmap for you. So yeah, we'll open up the session for any questions if you have.
Just we proceed for the questions. I have one thing.
Sure.
So we this week we will be having a lot of webinars, the same timings, and we'll cover different topics: project management, business analysis. So I have just shared a link on the chat, so you can go and register. And yeah, you will see you in the next session. You can continue with the questions.
Thanks, Soumya.
Do we have any question? Anyone wants to ask anything regarding the regarding data science, career related thing, anything you can ask.
Yeah, we have
Will
a
this,
yeah.
go ahead, Priya.
Yeah, we'll definitely upload this on our YouTube channel, right, Soumya?
Yeah, or maybe if we'll not upload, we'll mail to the attendees
Sure.
the recording.
Okay, great.
Hello.
Yeah,
Yeah, I have a question. I don't know whether you have covered this. I'm joining while I'm working. So,
sure.
what are the certification as a fresher? Currently, I am a business analyst. So, if I'm going to data analytics side, what are the certifications out there that I should start off with?
Yeah, so basically, there is a list of certifications, but as you said that you're a business analyst and you want to start off with your analytics journey, I would say that the IBA certification of Certified Business Data Analyst is should be your best bet to start off, right? We'll be covering this more about the certification in one of the next sessions, so you can gain more insight about it later on. So that is one certification. Plus, there are other certifications like entry level certifications. We have the ACAP certification. I mean, we can send you a list of different data science certifications available, right from basic level to the advanced levels. Maybe we can email that to you later on. But yeah, there are quite a lot of specific data science certifications available in the market. But I would say that given your background, it would make more sense to start off by bridging business analysis and data scientists work as a business data analyst, and then depending on your interest you can either move on to that role as a data scientist by applying or getting certified, or I mean you can decide based on your interest then.
Got it. Thank you so much.
Sure, great. We have one question from Tom earlier. It sounds like you would classify business data analysts per the IIBA as data scientists. Is that your position? Okay. So, yes, definitely we would not classify business data analysts as data scientists, right? Because, see, business data analysts, they don't work on the model building, model creation, the actual mathematical and statistical things, right? That is done by a data scientist. What a business data analyst does is they are bridging the gap between what the business needs and what actually is the data scientist doing. Are they aligned, right? So definitely, Tom, we will be covering quite a lot of details about business data analysts and the difference in their work in the upcoming business data analyst webinar. So I mean, if you can join that session, it will give you quite a lot of insights.
Yeah. The
Sure.
reason I asked the question is because on the slide, when you were talking about data scientists and the underlying skill sets for data scientists, most of that is directly attributable to business data analysts.
Yeah, correct. So I would say data visualizations are some of the key skills which are common to both these roles. Also, uh, the level of depth, right, is different for BDAs and data scientists. So BDAs also need to understand machine learning models, but they just need to understand at a higher level. Whereas data scientists actually have to go in depth and work on those models. So yeah, there is a difference in the expertise required.
So do we have any other question? Okay, then I think it's time to close this. So thank you everyone for joining. It was really great to have you all. And thank you, Priya. This was a very good session, very insightful, I must say. And hope to see you in the next webinar, which is tomorrow, on how to become a business analyst. So if you can register, you'll get the link there. Thank you, everyone. Thank you once again.
Thank you so much for joining this webinar.